Okay, so as I mentioned, all the questions are from Alex. They'll look exactly like this with slightly different numbers. If you've been keeping up with Alex, you should recognize most of these problems from Alex. So if you haven't done your Alex for this week, I would recommend doing it before the test tomorrow to not only get points for Alex, but also study for the test. There's a couple on here that aren't on Alex or haven't been assigned on Alex yet. What I'm going to do is usually when I post, like, schedule stuff for next week, I don't have it post till Saturday. What I'm going to do is I'm going to post a few for next week, but have them like show up today. So if you want to use them to study for the test, you can do that. So as I get to these, like I said, some of them haven't been assigned on Alex yet, but I'll assign them tonight, and then they won't be due till next week, but you can use them to study. So for the first question, are the triangles below acute, obtuse, or right? So for triangle A, it has one right angle, so therefore it is a right triangle. And then for B, it has one obtuse angle, and if it just has one obtuse angle, then it is an obtuse triangle. And triangle C, a right angle, so therefore it's a right triangle. And then for D, it has all acute angles, so therefore it's an acute triangle. So in order for it to be an acute triangle, it has to have all acute angles. You'll notice in the right triangle and the obtuse, it does have acute angles, but for it to be an acute triangle, it has to have all acute angles. Okay, next, number 2. Number 2 is whether the triangle is scalene, isosceles, or equilateral. So here, triangle A, it shows two sides equal, so that is isosceles. Two sides equal is isosceles. And then for B, all of the sides are equal, so it is equilateral. And some of you that have done this on Alex know that it's also isosceles because it has two sides equal. So all sides are equal, so that means it's equilateral, but it's also isosceles because it does have two sides equal as well. And then for C, all sides are different lengths, all sides different lengths, so therefore it is scalene. Okay, next one. All right. Just make sure he's not dying. Oh, geez, I'm recording. Anyways, okay. Of a triangle, all the angles of a triangle, or how do I want to write it? Angles of a triangle add to 180 degrees. Which should be pretty much common knowledge in your head at this point. So to find the missing angle here, 180 minus 40 minus 33 equals x degrees. So you would subtract this in a calculator. There'll be a calculator on the test. You could also just use one of the ones off the wall too. You subtract this and you get 107 degrees, and that is that angle there. Next. Okay, the next one, value of x here. So for this one, these two angles add to this angle right here. So you could set up an expression like this to solve for x. So this plus this equals that number, so we subtract, and it comes out to x equals 43 degrees. So for this one, you're either going to have to like subtract to get this angle, or you might have to add these two angles together to get this one. You could also use the concept as well, which sometimes I prefer. These two angles add to 180 because they're a linear pair. So 180 minus 148, 180 minus 148 is 32 degrees, and then you could use the 3 angles of a triangle to find that angle too. So whatever works for you. Okay. Then the next one, this is one I don't believe is this one on Alex this week? I don't think it is. So I will put it on there, and then you can use it to study if you'd like. It says L and M are parallel. Find the value of x right here. Well, since L and M are parallel, these lines are then transversals, and then all the angle rules for parallel lines with transversals apply. So alternate interior angles are equal. Alternate interior angles are equal. So therefore, if this is 50 degrees, this is 50 degrees. And then you can use the 3 angles of a triangle to figure out x. So 180 minus 101 minus 50 equals x. And that comes out to 29. Okay, next. I've also uploaded this PDF on Schoology, so if you want to print it out and work through it again tonight, that would be a really good way to study. Next, okay, other side. Well, do the paper. That is mine. Yeah, let me grab another copy. Okay, number 6 right here. Okay, this one is a little bit more complicated. I'll make it easy though. It says that these angles, or these expressions, are represented by these angles. The angles of a triangle, as you know, add up to 180. So we're going to put this plus this plus this equals 180 to solve for x. And then it says find the degree measure of each angle. So we need to then plug x back in to find the different angles. So this plus this equals 180. So 2x plus 5x minus 2 plus x plus 6 equals 180 degrees. So this one you might want to put a star 3, that you might want to practice this on your own a couple times. So then we combine the like terms. So 176 divided by 8 is 22. Which is cool, but it's not asking for the value of x, it wants the value of each angle. So once we have x, we need to plug that back in to each of these. So we get 44 degrees, 28 degrees, and 108 degrees. Like I said, everybody will get a slightly different problem with different numbers. One of the problems like this, it shows just like a 90-degree angle here. If it just shows that without an expression, then that would be 90 degrees, and you would just use that as part of your equation. But for all of them, you'll just be adding the different angles up, putting them equal to 180, and solving for x. Okay, halfway done. That was 1 through 6. It's easy again on the next one. We're playing some matching. Number 7, it says the triangles below are congruent and their corresponding parts are marked. Name all corresponding congruent angles and sides, then complete the triangle congruent statement. So we are matching here. It says angle A is equal to what? Well, there's 2 lines right here for angle A, so angle X on the other one would be its match. It's that simple. Angle B has the 3 lines, so the match over here would be Z with the 3 lines. And then C has one arc, so Y over here would be its match. Then for the segments, the same thing. Segment AB with one mark equals XZ over here. AC with 3 marks equals XY with 3 marks. And then BC with 2 marks equals ZY with 2 marks. And then triangle BCA, we're writing the congruent statement. When you write this, it has to be in order. So BCA is 3 lines, one arc, 2 arc, 3 arc. Yeah, so I have to do that same pattern. BCA would be ZYX. Okay, next one. Next page. Or on top of it. Question 8. This has to do with the side, angle, stuff. Probably saw this on Alex. So it says, find each figure, for each figure below, determine by using the markings if there is a pair of congruent triangles. If there is, name the congruence and give the property justifying congruence. So what we're looking for is either side, angle, side, angle, or a angle, side. And remember that ASS isn't one for these. Okay, so for question A, I see angle, side, angle right away. So I'm keeping that in mind. So that means they are congruent because I have one of these. And then the congruent statement, I need to make sure that everything matches as I go through it. MNO, so it's 2 to none to 1. So 2, none to 1. RPQ has to be in the correct order with everything matching. And then by the, I already wrote angle, side, angle. That is that. And for B, same kind of problem. It has angle, side, and it doesn't give me enough information. So not enough info. They could be congruent, but I can't prove it. So this one's not necessarily congruent. And when you click that, then you don't need to fill in any of this because they're not congruent. Not that we can prove. And then C, this one, we have angle in common and then a shared side. So we have angle, side is what I see. So they are congruent. And then naming the congruent triangles, I would say UVW, and I need to make sure it matches. U is a 90-degree angle, so I put X. V is the one that's labeled here, and the one that's labeled over here is W. V, like that. And then I would say angle, side. And that one's on Alex for you to practice as well. Next one, some proofs. Lovely. Proofs are scary, but like I said, a lot of the things repeat over and over. So if the more you do, the more comfortable it becomes because you realize, like I said, it just repeats. So given starts out BC is congruent to DC. You'll just have to fill in DC right here. I'm just copying it there. And then the next statement it gives us is also a given. And there'll be a drop down here where you just choose given. And then what I'm also doing is kind of marking this up. You could lightly kind of write on the computer screen or just draw it on a piece of paper so you can mark it and see what's going on. So BC equals DC and AB here equals AD. So we got side. And then I know I can prove this is equal to itself to get side, and that's exactly where the proof is going. So AC equals AC because of the reflexive property. And then from there, if you have it marked, then you can easily see the side. If you don't have it marked, it gets really hard. And this will be a drop down too. Okay, next one, again, it repeats repeat the same situations over and over, starting with given. EF equals GF, and I'm marking it on here, or drawing it on a piece of paper and marking it. Then it says EDF, so this angle equals GHF. And then this blank right here, GHF, just copying that. So I got like a side and an angle. Then the next one says that DFE, this angle, is equal to HFG. Okay, those are vertical angles. Cool. So my drop down, vertical angle theorem. And then last but not least, it says they are congruent. We got angle, angle, side, angle, angle, side. Okay, and then 11, next one. Okay, 11 has to do with the hypotenuse leg congruence property. So hypotenuse leg is when you have two right triangles. They have a hypotenuse in common and a leg in common, and we call that hypotenuse leg congruence. It's essentially the ASS theorem, but we don't call it that. And the ASS one only works for right triangles. They call it hypotenuse leg. Yes. So in these, it's just asking if you can use hypotenuse leg. So that's what we're doing. It's like yes or no. Well, the first one, A, the hypotenuse is the same as itself, and a leg. They're both right triangles. Cool. You have a hypotenuse in common and a leg in common. So yes, you can use hypotenuse leg. And this is one I will put on Alex today. So if you want to practice it, you can. For B, it has a leg in common, a 90-degree angle, which you need, but it doesn't show that the hypotenuse is the same, so no, we can't use hypotenuse leg. And for the next two, C, we have side angle side, that's cool, but it's asking about hypotenuse leg, and you need a right angle for that, so no. And then for D, hypotenuse is the same. There's a leg in common and it has a 90-degree angle. So yes. Last but not least, this one is all about equilateral triangles and isosceles triangles. Oh, sorry, I didn't realize you couldn't see that here. Equilateral and isosceles. And it says to find the angle measure of V. Well, with an equilateral triangle where all the sides are the same, all the angles are then the same. So to find the angle measure of an equilateral triangle, you take 180 degrees divided by 3 and you get 60 degrees. So all of these angles are 60 degrees. It's specifically asking for angle V, and so that would be 60 degrees. And then for isosceles, the two base angles are the same measure. It shows these two sides are the same. This would then be 40 degrees. It's asking for angle X though. So to find X, you need to do 180 minus 40 equals 100. So X equals 100 degrees. That's all. Okay. So like I said, if you haven't done Alex this week, make sure to do it before the test tomorrow because a lot of these are on there. I'll also, probably during my planning period today, be adding more to Alex that's on here. So if you want to use it as a study tool, I highly recommend it. I'm going to try according to how much time do we have left in class. There's not Schoology homework, just Alex. I'm trying to get this recording off. Where is my mouse?